Hey, QE Decoders, this is Michael. Jan will be joining us shortly, but in the meantime, I want to tell you a little bit about. Oh, here we go. Good evening, Jan. Afternoon. Good
And
afternoon, Jan.
good afternoon, Michael. 5 minutes short.
Oh my goodness.
No, I was still struggling with LINQ.
Okay.
I struggled with that a few years ago, and I'm still struggling with it.
Mm.
Um, I think.
Oh goodness. Yeah, I always struggle with the group by syntax in LINQ. It doesn't match my intuition with respect to how SQL does group by. It's a bit more collection oriented. Um, yeah. So what specific issues are you struggling with?
Well, group by.
Oh, okay. There you go.
Wait, I'm first gonna shut down a virtual machine because otherwise
Mm.
everything is gonna crash again. Um, that virtual machine that is called historical modeling.
Mm-hmm.
Right, so he's saving it, stopping saved. Okay, so now let's try to share it. By the way, did you get the text tree? Did you
Mm-hmm.
get the feedback on the first chapter?
I did. Yes. Thank you so much.
So there was, it was,
Oh, and it
he,
stopped.
he crashed it.
Mm-hmm.
Right, let me try to close a few other things then. Internet Explorer, yeah, that one no need. Um, let's close everything.
Okay.
And see what that. Wait, but now I have to. Where's my Visual Studio 2022? No, the first chapter
Mm-hmm.
is actually very good. Um, and it was very nice to read in the first chapter about the upcoming proofs.
Uh-huh.
But the setting is that you have to wait for that until the last two chapters.
Yes, yes. But
Um,
there's a lot of work to be done before those proofs would really make any sense or be in context. Yeah.
mm,
Um, yeah. In
um,
fact, yeah, it wasn't until completing the first edition and
mm,
then working on Janaga that I was like, wait a minute, we need
yeah.
better proofs here.
Okay, it seems to work for the moment. It is readable.
Yes, yes, it is.
Now let's see, because I even didn't didn't save the last testing. Um, Wait, there we are in the SQL store. No, it's not the Q bookmark here. That also not. It was in the read here. So execute the query tree. No. Then load types of specifications. That one we did last week.
Mm-hmm.
And now we were working on the roles.
Okay. Oh yeah, you need
So
to retry fact type ID. Yeah, that makes sense.
yeah.
Yeah.
So I got these get all roles from specification. That's what I got from you. Copied
Yes.
from the test. So we have the roles with the fact type names.
Mm-hmm.
Then we get them by the fact type IDs by going and look into the fact type map,
Right. Yes.
which we already loaded before that. We
Mm-hmm.
updated before that. So to find my unknown roles, I'm gonna see uh, first whether the fact type ID is already
Mm-hmm.
in the cache, and if it is, whether in that sub dictionary I find the role name.
Right. Yes.
So if it is not found, then I have an unknown role.
Mm-hmm.
I'm going to load that from the SQLite database.
Okay. Yes.
Struggled a little bit with aggregate.
Mm. Yeah. Yeah, I can see that.
Um,
Yeah, so you're um, concatenating a collection of tuples with
yeah,
commas.
yeah. So in fact, what you get is
Being,
where this tuple
mm,
is in values, and then you have this bracket is absolutely needed,
mm-hmm.
and then you have all the brackets, all the tuples, one behind another.
Yeah. Yeah, stream.join might be a way to simplify that. So
Um,
you do a dot select in order to get um, the name the item one comma item two pair, and then you do a string.join over that collection to separate them with commas, and then you don't have to take the comma off at the end because it just does that is the join character.
is there not a simpler thing than this? I
Mm-hmm.
thought you had, if you just say in between brackets and then a C, in my mind it would be a character, just to define a
Hmm.
literal, but was that JavaScript? I don't know.
That
Um,
yeah, that sounds like that's the way that it evolved from C, and C sharp obviously is a C
yeah,
variant. Yeah.
well,
Well, if we were to use string join, then that part wouldn't be necessary anyway. But
it's equal RC?
oh,
No.
that okay, that syntax I don't recognize. Don't know where that comes from. Um, but
No.
single quotes instead of double quotes should give you the character version.
What am I doing? Is is
Yeah.
this gonna be a character? Yeah, it's a character. Indeed. So if I would uh, leave this one, and then I have to one more, and I make it single quotes.
Yeah, and Visual Studio helps you by having the close single quote.
Perfect.
Yeah.
Perfect. Okay.
Okay. But it could be
So
even simpler with the string.join. But we'll we'll get to
and
that
then
later.
will that be faster than with an aggregate?
Um,
Or
I'm
just
I'm not certain about the performance of that, but
yeah.
that seems like um, kind of the nitpicky. It's probably is going to be faster. I think yeah. So string.join is
Mm,
doing all the work internally, so they probably used spans and
mhm.
string builders that kind of thing. And with aggregate, they don't know what you're doing, so they just keep calling you back, and now you're using string concatenation. Um, so it probably would be
Yes.
faster.
Okay. Because in the first one here, I use the string.join. Where was it? Here, I
Mm-hmm.
used string.join.
Yeah.
But so this one I have to apply then after the select.
Yes.
Okay.
Yeah.
I thought let's do it
But
with aggregate, uh,
yeah.
which is which gives me headache. But okay, I get my roles out of here, loaded roles.
Mm-hmm.
But then I have to get them into a dictionary.
Mm-hmm.
And then things are going wrong. I thought I found a very nice example here because you had this from your tests, you
Oh,
had this
right.
get all roles,
Mm-hmm.
which actually I'm not using um, because this starts from I use get
Yeah, you
all
get all
roles
those
from
from specifications.
specifications,
Yeah.
and I don't have to add these artificial role IDs.
Right.
I have to load
Yes,
them
you have the real
from the
ones.
database.
Yep.
But so in fact here So I thought, okay, I'm starting. I do have that, my role ID from the database, my role name, and my fact type ID.
Mm-hmm.
But then I have to get them in this dictionary with a subdictionary.
Right.
Yeah.
Right.
So I thought, okay, let's copy this and copy it in here.
Mm-hmm.
But there, what I get out of it is something funny. Um, let's run the debug. So my store test, put a breakpoint here. He's getting there.
Mm-hmm.
So the unknown roles here. Uh, do you see that window or not?
No, I just see the main
Yeah.
window. I don't see the.
Okay. Let's add it to the watch.
Okay.
So here you see.
Okay.
So you have
Yeah.
one
So there's
element
the
with
fact type, and
three.
then.
Yeah.
Mm-hmm.
Fact type ID and the role name. These are in the database.
Mm-hmm.
So we should return a role ID of 2. So if we continue, yeah, just let's go straight there. So the loaded roles now.
Mm-hmm.
Yeah, let's add that to the watch also.
Okay. So we've got.
So you have, where is it? Yeah, here.
Okay.
So the role ID 2, the name airline day, and
Mm-hmm.
the fact type ID 3.
Okay. Yep. So I've got that
Um,
from the database.
yeah. So far so good.
Mm-hmm.
And now I have to get that into an immutable dictionary. So
Right.
let's try that step. And yeah, add this one as well to the watch. But then here I'm getting a key
Mm-hmm.
3.
Which should be the fact type ID,
Huh?
and
No,
then
it's okay.
yeah, um, and then
Now
yeah.
now it's okay.
Hmm.
Why it was not okay before?
Yeah, yeah. I've been reading over that code, and it's like I can't see anything wrong with that code. This is going to produce the right results, and yeah, sure did.
Okay. Then no, it was giving me a lot of rubbish there.
Hmm.
And then, but before I had the group by directly underloaded, so now I defined an additional variable, and perhaps I did something wrong before. So now I can test the next one here. Um, let's dive into that, because the merged roles I never tested, and
Mm-hmm.
also there I like the for each loops.
Yeah.
I'm sure you can write it in LINQ in one time.
Yeah.
you you can just type it in LINQ directly, but so
This is a lot easier to read and understand. Yeah, the other one I had to
yeah.
reason through. It's like, okay, that second one is the value selector, and so it's going to give me back an IEnumerable of those key value pairs. And then when you do two immutable array, it's got an IEnumerable key value pairs, and so it's able, or immutable dictionary. It's able to do the right thing. Um, but yeah, there's like uh, you know, 3 lines and a whole bunch of cognitive space between creating
Mm.
the pairs and then turning them into an array. That yeah, the loops just eliminate all of that cognitive dissonance.
So I haven't get here yet, but so the loaded roles, I have my role cache.
Mm-hmm.
My role cache, which comes in here. And I have my loaded roles. Both are dictionaries of the same type. So
Okay.
I go to my loaded roles, go through them. If the role cache contains the key that I
Mm-hmm.
have in my loaded roles, then I add
Ah,
the dictionaries.
yeah, that's an immutable dictionary, so it's, yeah.
Oh, yeah.
I make
So,
that mistake all the time. Yep.
um,
And
no,
actually, yeah, that's not going to work because it's immutable. Um, yeah, you're going to have to call role cache dot, is it put? Um, but yeah, basically you're replacing the value at a certain key with another value, and then you set role
yeah.
cache equal to that.
Um,
So
what was it? Was it set? Set items, sets in an immutable. Yeah, set
yeah,
item or set items. That's so
yeah. So if you set
it's from.
item, and then you pass in um, x dot key, and then you also pass in that expression that, you know, the
Yeah.
results of add range.
So I don't have to do the add range.
You do. That's going to be the second parameter to set item.
Yeah. Right. So it's gonna be like this. Set role cache dot set item. So the key is the x dot key.
Yeah. But then the value
And
is actually that whole expression. Role cache
um, okay, yeah.
at x key dot
Role
add range.
cache. So that's the old one.
Mm-hmm.
X dot key and then dot add range
Yes.
and like this.
Yep. And you also need to assign that back to role cache.
Why assign that?
Because set
Because I've
item also returns a new immutable dictionary.
does it? Yeah, probably. So role cache equal to
Yes.
like that.
Yep. Yep.
And otherwise, so if it doesn't contain that, I add a
Mm-hmm.
new element to the role cache.
Mm-hmm.
There I assign it to role cache again.
Yep. With all
So
of the with that sub dictionary from what you just loaded, just pop it in there. Yep.
yeah, that was the x dot value.
Yep.
And because there was nothing else, I didn't have to do an add range there.
Yes. Nice.
Okay. So let's see what happens here. So my role cache is gonna be what now? One more. Add watch. There is something in it. I have a key of 3.
Mm-hmm.
And I have a value. Yeah.
There it is.
A key of 3. Yeah, that's correct. It's 3 is my
Fact type ID. For
yeah, yeah. And 2 was the role ID. Yeah, okay. So that
yep.
works. So if we continue, the next time it comes in, because he runs through the same specification.
Mm-hmm.
So now he should not find any unknown roles anymore here. Why is nothing in it here.
Mm-hmm.
Sorry. So he jumps over it and he returns the roll cache, which is still the same, and then
Mm-hmm.
he will still go through a third time, and the test is finished.
Very nice.
But so this test was actually not really testing; it was just for debugging.
Yeah.
Um,
Yeah.
what is he doing?
Yeah. There was no failure for.
Oh, he's still running somehow.
Oh, and then crash.
And he crashes. Okay, I didn't save. That's not clever, but say recover the file. I hope it's gonna work.
But we have the recording. You could just retype it.
He said, "How did the stream go?" He's asking me.
Well, let me tell you
um,
how the stream went.
let me see whether we have the. There was in the read. Where was it here? Get all the fact types, get all the role types. Role cache.set item. No, not everything is there.
No.
Wait, first let me save that one. Then
That reminds me of an experiment. I'm trying to remember the name of this blogger, but he does some really interesting just code experiments. One of them was a unit test runner that would delete any code that failed a unit test. So it was just from the inside out, just oh, failed, test failed, bump, 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 until it got to test pass, and then say, all right, that's it. So it was a very stressful way to test.
that's yeah. So no, he missed this one.
Okay.
I think the rest was okay. Set
That looks right.
items, yeah, and that was okay. So I think if we run it now,
Leon Bambrick, or was that his name? I think that's close. You'll be able to find.
it doesn't say anything to me. That name.
Yeah. Okay. Well, it just popped in my head. It's like, yeah, that's a terrible idea. I love it.
Okay, and now it passes. But so actually, this test was nothing more than here running a number of times through the same specification. That's all it is doing, just to see whether he loads the first time, he get it in the cache, and he doesn't reload it afterwards.
Yeah. Yep. And like you say, just for debugging, if that were for testing, then there would be some way to kind of peer in and see what's in the cache and what's not. And that would be a hard test to write. And it would also break encapsulation. There would be implementation details in the test, which you don't want.
Because also one of the things I was struggling a little bit with. So I use this in the tests. You can get this output here, the standard output, and that was using this one here in the constructor of the test. Now, if in the routines that I want to test, I want to use, for example, debug write line, it's not working during a test. So actually, I didn't really search for it, but so the way to do it would be to pass this output parameter also to the routines to be tested, which is absolutely not what we want.
No, because at runtime we're not going to have that. And yeah.
Did you find any solution for that? Or you never?
There, I don't know that I've actually used this solution for anything, but the thing that comes to mind is to put an abstraction around it so that for when you're testing, you can just send stuff to output, but then when you are running in production, then instead it sends it out to the logger. Um, in this particular case, well, yeah, this is all running client side. Yeah, I do need to figure out the logging story. Um, is this too much information to log for the application developer? Um, yeah, I don't know. It might be interesting on the one hand to be able to capture a log of um, all the SQL commands that it runs, um,
Mm.
but then on the other hand, that might be more than an application developer needs. They'll see all of this, all of these generated SQL statements, and they're like, okay, I see that it's doing something and it's working, but what does it mean to me?
Mm. But so just to inject the logger that he wants to use in that case.
Yeah, yeah,
Mm.
yeah. So then we can have an implementation of that logger that's specifically for the test output, and then
Yeah. Mm-hmm.
another one for Microsoft logging or whatever.
That might be a good idea. I will look into that. Yeah, so this one, I think I should still test a little bit more and then just do a pull request.
Yeah, yeah, yeah. I don't think your test is going through that line of code that we just changed. Um, so yeah, coming up with a test um, that loads from or load saves. Anyway, it did that exercises pulling some of the roles, but not all of the roles from a particular fact type, and then coming back and getting some other roles. Um, so yeah, that could be done by giving it two specifications. One that is joining from one side, from one set of predecessors, and then another one that's getting some other predecessors.
Yeah, but how with the unit test I can see whether it comes from the database or it comes
Mm.
from the cache.
Yeah, so the way that I could think to structure a test without getting too implementation specific would be to test the number of times that it runs a query, and uh, and so before putting the caching in, and you call that specification. So take this exact one here. So you've got one specification, you're calling it 3 times. So before you add the caching, you would expect it to hit the database 9 times in total. So get the
Yeah,
facts, get the roles, run the specification, then facts, roles, specification, 9 times. But then after, you would expect the number of queries to drop to 5. 5 queries. So 3 for the first one, and then 1 for each of the following 2.
yeah. But that number of queries, I don't have that information as a
Yeah,
result.
yeah. So I think to get that, you would want to insert a shim between between the code under test and the SQL layer. So um, so like the connection factory and the SQL connection. Right now, that's not abstracted away, so there's no way to insert a bit of code there. But yeah, if yeah, and this is a lot of work that you're just solving with debugging. So I'm not sure how viable this would be. But if you were to extract um, the SQL connection factory, put that behind an interface, and then the SQL connection that it gives you back would also be behind another interface. Um, Then
Mhm.
runtime, you're just using them raw. But then for test time, you put a wrapper around those that as it passes through, um, create connection creates the wrapped connection object, and now that connection object, when you execute a query, it just increments a counter. And then after the test, you can check the counter
Mhm.
of that wrapper.
Yeah.
It would have to be a counter in the SQL connection wrapper. So each one of these increment that counter. Yeah,
Not, that's not
it
that
sounds like a lot of
difficult.
work.
Um, well, every time we open the connection, anyway, we have here
Mm-hmm.
the with connection routine.
Yes.
Every time we go in, um, have to be careful with, because if it
Mm-hmm.
is if he returns because of a failure, he calls that one again, I think.
Yeah.
Let's let's think about that.
Yeah.
Um,
Yeah, there's value in the code being simple and easy to trace.
mm,
You just you call this function, you can see, okay, there's the implementation of that function, and it returns these objects. Versus, yeah, you call this function, and then it's just using some interface that you injected, and so you have to find what's the implementation
mm,
of it. Um, so yeah, you can't get crazy by um, having all these places where you can um, insert these test shims. Um, so yeah,
because also
I'm not convinced yet that this is an
mm,
important place to put a shim.
because also you can test based on timing also, uh, with cache and without cache, and
Hmm.
you run it thousand times like I did manually last
Right.
time.
Yeah.
But also there, then you have to be able to run it without cache. So you
Yeah.
need an additional parameter to switch it off, uh, which in production is never going to be there.
Yeah. Um, yeah. I mean, I guess uh, that has the advantage of testing the thing that you actually want to affect. You really just want to affect the time. Um, and then the way that you can have the before and after picture is test-driven development. So you put that mechanism in and collect timings before you implement the cache. So maybe do that on another branch. So okay, I've already got the cache here, but now go to another branch, put that mechanism in, um, and then gather some timings, but then set the threshold for the test to pass below the time that it actually takes, so that the test fails. And then when you um, rebase your changes back on top of that, see if the test passes. And then it might only pass and fail on this machine, but then future machines, the non-cached version would have passed anyway.
Yeah.
Yeah,
Mm.
it's a little bit
Um,
fragile.
or just put an optional parameter in the routine that you can switch off the cache, and so the testing uh, passes, runs without and with cache.
Mm-hmm.
And it just say if you are below half of the time with cache than without cache, then it's
Mm-hmm.
okay.
Yeah, yeah. I'm still coming down on, you know what? You debugged it. Looks like it's working. Um, do a few more tests to make sure that you get correct behavior, and then you can trust that it's caching in order to get you that correct behavior. Just testing the correctness of the cache
Yeah.
rather than testing that it is caching.
Okay.
Yeah.
Oh, because otherwise the testing becomes so complicated that
Yeah.
we're gonna have bugs in the testing.
Yeah.
Um,
Yeah. And that further complicates the code under test. Um,
mhm.
Oftentimes, making code more testable improves the quality of the code. I think this is one of those cases where the opposite is true.
Okay, let's keep that into mind. So I will test it a little bit more, and then I upload it for a pull request. And then
Excellent.
finally, the two caching have been implemented.
Very nice. All right. Yeah, I've. Oh yeah. Last time we talked, I promised that I would show um, what it was that I found when when testing with Blog Maui on a device. Um, Still in the simulator, actually. My device testing is still ongoing, but I'll share that next week. Um, but yeah, I found a bug that actually we saw a few times on the stream, and I just didn't know what was happening, and looked confused, moved things around, and then it started working. So said, okay, we'll look at that and move forward. But spent some time looking at it, and turns out that there was a problem with the proof. So I can show you what the bug was. A test that reproduces the bug reliably, and then show you the problem with the proof. So let's do. I think you're still sharing, by the way. Okay, and here is the bug in test invalidation, and I'm using 0.8.2 because now 0.8.3 is out and it fixes the bug. So I can only demonstrate this with 0.82. So the problem is that you might have recalled that in Blog Maui you've got the list of all the blog posts. You go into a post, you edit the title. When you come back, sometimes you saw the old title there, and then you'd hit refresh or you'd just navigate, and then the new title would appear. So I figured out what was causing that. And the sometimes, as you might imagine, is caused by a race condition, but the test that I was able to put together gave us a very well-behaved and predictable reproduction scenario. So let's say that I've got a company, Contoso, in a city called Dallas. And so we open a new office, and now we name the office Dallas 1. And that has no predecessors. That's the first one. Then we decide to change the name to Dallas 2, replacing Dallas Office 1. And then we change it to Dallas 3, replacing Dallas Office 2. So a very simple chain of changes to the mutable property. Yeah. So far, so good. Oh, by the way, .NET 8 is coming out, and it has it pairs with C# 12, which has the best language feature ever. We can now, with C# 12, this won't work right now because I don't have it installed on this machine. Instead of this, we can say this. And so instead of this, we say this. And this. And it does what you think it should. The same thing that it does in JavaScript. It's amazing. Okay, but until I get this project upgraded to C# 12, that's what it would look like. So we've got our string of office names, and so now here what I'm doing is I'm setting up a fake network. And this network has a couple of feeds in it. So when I run a query, then it's going the Janaga client is going to talk to the network and say, hey, give me the feeds for this specification. And it says, oh yeah, these are the feeds. It just kind of fakes those in there. and then say, all right, great, give me the facts for those feeds, and then it just streams back these fact IDs, and then it loads them from the fake network, and then it gives you all the fact information. So we'll just pretend that these are the two feeds that you get. So in this situation, the view model and load Contoso, that you would end up with a single office which has the name Dallas 3. Why is that? Well, load runs offices in a company. So give me all the offices that are not closed, and then give me all of the names for each of those offices. And these are observables. So so when you give me back the office names right here, I can call onAdded because that's observable.
Mm-hmm.
And then I set the name inside of the office view model.
Yeah.
So that's that is your typical connection of a specification watch to a view model. That's what that kind of thing would look like. And so you would expect that you have a single office named Dallas 3, and when you run it, you will find that it fails. And it fails because I expected Dallas 3, but I found Dallas 2. Why would I see 2 and not 3? This happens consistently. Part of the reason it happens consistently here and not in the real world is that in the real world I actually end up with 3 feeds. One of them has just the predecessors in it. So it's just got name 1 and name 2. So there's a bit of a race condition between this one and that one. But when I pare it down to just these, I eliminate the race condition and I always lose. So I always get the wrong data. So why is that? So I put together this this document to kind of describe why that is, and it's to do with the invalidation. So I've proved a theorem about the query inverse. That that when you receive information about a new fact, the inverse tells you all of the projections that need to be updated and exactly how to update them. And if that were the case, then you would get the right answer. But I'm not getting the right answer, so clearly there's a problem with the proof. Here's what the problem is. We've got this view model, or this model. So that's the model that we just tested. So we've got companies, cities, offices, and then the office name and closure, so that you can do the isClose thing. Then we've got this specification that we just saw, copied straight from the view model. So I've got the offices and company. And then I want to compute the inverses of that offices and company specification. This is going to give me back a collection of inverses, not all of which I'm interested in for this test. The ones that I'm interested in are the inverse for when I learn about a new office and when I learn about a new name. Let me do one more thing right here, and let's look at offices in company to descriptive string. So this is what the specification looks like in the factual language, which, as you've noticed, I'm actually adopting this syntax for factual in the book, so I'm bringing those two worlds together. So given a company, we're going to find all the offices in that company such that there does not exist a closure. And then with each one of those, find all of the names for those offices, such that the name is not replaced. There is not a next. And then just give me back all of those values. So I've got a collection of strings. So that is the original specification. And now to compute inverses, what I do is I look through this specification and I pick out all the labels. And then I grab the tree by that label and shake it, so that label now becomes the given, and everything else kind of falls out and becomes labels. So when I shake the tree by the office label right here, then what I get is a specification that says given an office, find the company, and then find all of the names for that office. So it's just the same specification, just reoriented to use the office as the input. When I take a look at the inverse, starting with the name, then here I've got the name, and from there I can find the office, such that there's not a closure for that office. And then I find the company, and then I'm really only interested in the names.value. So the way that I use these inverses is I just learned about a new office name. So let me run this inverse, find out which office it is, which company it is. And so when I have this specification starting from that company, I know that the results of the specification, the projection of the specification, have changed. In what way have they changed? Well, I've picked out a company office tuple. And so I know that that child specification, or that child projection, is what has changed. And then this name.value that I selected down here, I know that that is a new value to add to this projection of names. So I can compute the inverse, from there figure out what specification was affected, and then exactly how it was affected by finding the office. So the company tells me which specification, the office tells me which child in that collection, and then the value tells me what to add to that child projection. So this is where the fun begins. So in the client, I've already done all of this inverse calculation, and then I call the replicator, and I say, okay, give me the graph of all of the facts that I need in order to run this specification. So that's where the feed proof comes in. So far, it looks like the feed proof is holding up, so not too worried about that. But the graph that the replicator gives me back is this entire graph of the Contoso company, the Dallas city. Here's the Dallas office, and it's got a name Dallas 1, name Dallas 2, name Dallas 3. So that entire graph of facts that I set up at the beginning, that is what the client learns about all at once. It's that all at once that is the key to it. Mm-hmm. So we start to notify the application in topological order as we receive these facts. For each one, we run the inverses and see, do we have some things that we need to notify about from this point forward. So the interesting ones are the office and the name. So those are the two inverses that we looked at. So we're going to start by notifying office first, since that's the first one in topological order. So that means that we are going to run that inverse. I just converted that factual that we saw back into .NET so that I could run it as a j.query. And I get back a collection of offices having just one value in it. So here's the actual office fact. And then here are the names that match that specification. And we just get Dallas 3 because this specification contains not exist any facts of type office name next. So this is the only one that hasn't been superseded. It's the only one that, for Dallas 2, there exists a Dallas 3 such that prior contains Dallas 2. For Dallas 1, there exists a Dallas 2 such that prior contains Dallas 1. So these two are excluded because there is a next. That one, no next. So therefore, that's the current name. So I get this graph all at once. I run the first inverse, and that's the result I get. So I notify you, hey, here's an office, and here are the names for that office. So now you've been notified of the office, you've been notified of the office names. Then I go through each of the different names in topological order, because I've just received this graph, and so I say, okay, got to tell you about Dallas 1, got to tell you about Dallas 2, got to tell you about Dallas 3. And I go through each one of those, and as you might expect, these are the values that it gets out when it runs that projection. But even more than the values, what's interesting is the office that it's getting back as part of that tuple, and the name part of that tuple. And so now when I notify you of the office and the name Dallas 1. You've not seen that particular tuple before, so you take that. And then I notify you of the office and name Dallas 2. Haven't seen that pair before, so you take that. But then I try to notify you of the office and the name Dallas 3. You have already received a notification about the office and Dallas 3 from the very first inverse that we ran. So I'm trying to tell you about that office and that name, and you say, I already know about it. So the Janaga client has some code in there to prevent it from notifying you about the same tuple multiple times. So so that means it's going to dedupes the notification. So it's going to tell you about Dallas 1, tell you about Dallas 2. It's not going to tell you about Dallas 3 a second time. So coming back to the view model, and we can see what the view model does with this. There's load. The view model is on added going to just set the name property. So that's just a string. If that office view model already has a name, it's just going to override it. So when this office is first created, it gets the name Dallas 3, and then we call it back for Dallas 1, and then we call it back again for Dallas 2, and we filter out the callback again for Dallas 3, because we've already been notified of that one. And so we're left with the penultimate value, the second to most recent value. So that was that was quite a lot of reasoning
going through. Yeah.
But yeah, when I got through that, it's like every part of the code is doing the right thing. It's doing exactly what the proof said it should be doing. The problem is that I proved the wrong thing. What I proved. If you will take another look right here at this inverse. What I proved about the inverse is that when I learn about a brand new name, this gives me back the set of all of the all the projections that need to be updated. Part of that proof is the assumption that this name has no successors. If I go back here I am looking for the names where not exists a next, a successor.
Yeah.
So the proof says, well, I know that next is not going to exist. Therefore, this whole clause right here is a tautology. It's always going to be true. It says next does not exist. I know next does not exist because I just now learned about this name. There hasn't been time for you to tell me about successors. But when I put this in place and I use this upon receiving a graph, I actually have received successors.
Okay, if they are out of order.
Yeah, so I'm trying to notify you about Dallas 1, and I'm making the assumption that the successor Dallas 2 doesn't even exist. So I'm going to run the inverse, and I have eliminated the not exist clause, and so Dallas 1 is going to come back. Dallas 2, of course, is the real problem. So I do the same reasoning here, run that inverse with the assumption that Dallas 3 doesn't exist because I just learned about Dallas 2. So I run. Where's the inverses again? Yeah, I run this inverse, but I'm not checking to see if name has any successors, and so I am notifying. What I need to do is, instead of eliminating those not exist clause because I assume that they're tautologies, I need to actually run those not exist clauses. So the correct behavior here would be notify about the office, which gives you this this value exactly. Here's the office, and here's its currently known most recent name. And then notify about name, run the specification, but include the fact that that name has a not exist clause attached to it. That would therefore not return any results. And so notification about Dallas 1 just would not happen. Similarly, the notification about Dallas 2 would not happen because it finds the next. It didn't exclude that clause anymore. It runs it, finds next, says, oh, don't notify about it.
So automatically Dallas 3 will be the one that will be displayed.
Yep. It'll be displayed just in one shot, and there won't be anything coming back and trying to override it.
Mm-hmm.
So if I come up here and I go to 8.3, let's just see. Let's restart. There we go. All right. Let me reload the window. And run all. I didn't hit run all after restarting the kernel. That probably would have worked.
Mm-hmm.
But now, when I run the inverses, interesting. Why is that the case? Oh, that's right. I changed the name to Givens. It made a lot more sense that way. And I was like, why am I? Givens. Yeah, label. Yeah. Hold on 1 minute. This is not something that the application developer would usually be doing, so that change to the interface, I don't find all that damaging. But right here, this is the key. So given the name, corporate office name, such that not exists next. So I can attach a not exists clause to a given, which is why I changed the structure of given. So now it's not just a collection of labels, it's a collection of labels and existential conditions. So so now it runs the existential condition on the fact that that you just received to see if there have been any successors. It no longer assumes that no successors can exist. So yeah, my proof was invalid. I was assuming that the fact that I was just notifying was indeed the last fact that I had heard about, and I was not taking into account that I could hear about an entire graph and then notify about each thing in topological order. Now that I've taken that assumption out and I've put existential clauses on givens, then I'm getting the correct result.
Okay, it's nice that is solved in the library now.
Yep. Yep, that was a tough one. But yeah, that gives me just a whole lot of extra confidence that yeah, when I'm just playing around with the application in the simulator, it's like, okay, I've done all the proofs, I've written all the tests, everything looks like it's right, and then I run it in the simulator and I get unexpected behavior, and I'm like, but I did all the things. It's tested. It's proven. And so yes, I found the error in the proof. Fixed the fixed the code in order to use what I just learned from fixing that proof, and then the test pass and the behavior goes away, and I'm starting to get to the point that that I'm seeing expected behavior from the application, at least in the simulator, and giving me a lot more confidence that no matter what specification you throw at it, no matter what application you build, you're going to get the correct results.
Because certainly if it are results which only pop up from time to time, it's if it's so difficult to reproduce, yeah, as long as you cannot reproduce it, you cannot fix it.
Yeah. I was very happy that the test by taking away the other feeds and focusing on just those two feeds, that got me to the point where I was able to reproduce it every time.
Great, one more step closer to a very stable platform.
Indeed. Yeah. So yeah, next week I'll show the progress that I'm making for deploying the Blog Maui application to a mobile device. So I'm actually deploying Blog Maui to my iPhone, even though at the moment I don't own a Mac. So yeah, I'm doing all of this through CI/CD. It's the absolute slowest way to debug, but it's working. And so yeah, I'll show that working. And right now, the app on the device is not working, but I'll probably have that figured out and have a working device to show next week.
It's not working. That was still the problem from...
Nope, different problem now.
Oh.
But hey, one step at a time.
Okay.
Yeah.
And then one of the next things should be the login with Google.
Yes, that is next on the list after I get that full end to end. It's like, okay, this is a solid thing, and then hopefully I can build something that I would actually use day to day, and then just me using my own app. Uh, I would be testing things. So yeah, the blog uh, model makes a good demo because it's nice and simple and it's something that a lot of people would understand. Um, but yeah, building something um, useful that I would actually want to return to every day and do some serious work with would be a little bit more complex. But hopefully all the patterns are worked out, and then it's just a case of reproducing those patterns.
Great, great. That's a nice future.
Yes. Ah, yes. Yeah. And then, yeah, at some point we will return to the whole AI discussion and how does that fit in? Because yeah, I'm seeing a future where you can have a talk, you can discuss with a GPT. You know, this is the system that I want to build, and then it leads you through. Here's let's design a historical model. Here's the consequences of that decision. Okay, let's bring some data in. Here's some forms you could enter some data. We'll put those into a replicator for you, and then all right, this is starting to work. Let me go ahead and turn that into a mobile app, and here's some code. And uh, I think I think I think all the pieces are falling into place for that to happen.
And then the programs will be written automatically.
Yep, written by domain experts themselves.
Yeah. I'm still a little bit skeptical to believe that, but if we see how fast things are going now,
Yeah,
um, really wondering by 2050 where the technology will be.
yeah, yeah,
Um,
yeah. And I think it's yeah, not to get too deep into this concept, but um, the the things that we've seen out of ChatGPT over this past year. It made all these math errors. It makes all these factual errors.
mm,
But it seems to parse intent very well, and then give you back an answer that sounds like it's coming from somebody that has intent in return. And so then the things that OpenAI has been doing most recently are like, okay, let's hook these into um, these uh, uh, these adapters to adapt to a calculator, adapt to a search engine. So the model can figure out when should I generate some code and run that through a calculator, and then let that do the math, and then I'll just spit out the results.
mm,
So it figures out how to write that code. It figures out that it needs to write code, and it interprets the results correctly. So now ChatGPT does math just fine,
mm.
and then also now it can connect to the internet, and so yeah, it's making factual errors that a human with Google would make, rather than just making things up. So that's a step in the right
Yeah.
direction. Um,
Mm-hmm.
but yeah, um, so now you have a conversation with a GPT about a historical model. It doesn't know what in in and of itself, it doesn't know what the rules of historical modeling are, but it could be connected to an API that does. And then it can just drive that API. That API can do all the correctness proofs and then give you back a correct model. Um, and then it can discuss the consequences of that particular model. Say, hey, okay, because of this, this value here can't change, or if it does change, you get a brand new thing over here, and you don't keep that
Mm-hmm.
history. And describe that in a way that a domain expert would understand, rather than just show a graph and say, see, these are successors of a different thing than that. Um,
Mm-hmm.
and then do the same thing um, uh, with converting that into a user interface. What if we had a user interface specification that just described the intent of the UI, not XAML, not HTML, but just the intent of the UI, and then it could iterate with the user on that, and then render that intent right there on the screen, and you could enter data into a form. And then once it's iterated on that, send that model of the intent of the UI back to a code generator that then gives you a Maui application, gives you a React Native application, gives you a React application. Because all of that part is mechanical. And so there's no parsing of intent in that part of it. So yeah, I think by putting the pieces together just the right way, we can actually get to the utopia of people
because
developing their models.
you go iteratively through all these steps.
Yes.
Where you have the UI, you can test it. So in that way, you can really make the intent clear.
Yep.
Okay.
Yep. Yep. That's a real thing that can happen.
It's gonna be time to retire. For early retirement.
Yeah.
No.
I think we'll still be getting to just a. Let me get logged back in here. No, I'll fix that later. But yeah, I think there will still be the need for experts in technology. So I could see somebody taking this just far enough to solve the problem of let's get an application in the hands of users, collect data, share that data with other users. But then now, what do you do with that data? Do you run that through other AI models? Do you use that to call APIs? Do you perform some mathematical calculations on it? So all of these other things still need to be done, and so now you've basically done a whole bunch of pre-work. And now when a potential client comes to a consultant and says, "Okay, I need to take this to the next step," then a lot of that back and forth work has already started, and we can just go on to the next step.
Actually, we can just see it as a logical consequence. Before we were using assembler language. We were just machine code and then assembly. Right now we are using C#. But the next step might be that we just describe the problem and that we don't need a code anymore.
Yeah. Yeah.
Okay.
I believe that we can get there. Let's try. Let's see how close we get.
I think the next couple of years will be very interesting.
Yes, I think so.
Sometimes I think I would like to come back in 500 years, in 1,000 years to see what is what's happening with the world.
Yeah. There's an XKCD that kind of plays on that theme. There's a scientist that goes into a chamber, say, "Okay, wake me up in 10 years to see if we've solved this problem." She comes back out and is like, "Oh wow, the future is so great. Okay, put me back in for another 20 years." And they're like, "But wait, we need you to solve the problems. Stay here." She says, "No, I need to see the future. You need to build the future."
Yeah, and it's going always faster and faster. Since we have internet, there's really progress.
Yeah,
okay.
I'm an optimist.
Yeah. Why? I believe in the future. I believe in the future. Because I hear a lot of people who are getting scared by artificial intelligence.
Yeah. We do have to be cautious, absolutely.
Yeah, but before people were scared by the railway as well. So the first trains were we're gonna kill the cows, and it didn't happen. So I think with artificial intelligence, it will be going in the right way as well.
Yeah, I think so. If we stay involved.
Okay.
All right.
Michael, see you next week.
Indeed. I will see
you. And I will try to go through chapter 2 then.
Excellent.
One chapter a week.
Okay. Yep.
Okay.
Sounds good.
See you.
All right.
Bye-bye.
Bye.